Hi, Assalamualaikum. My name is MUSTAQIM bin Muhammad RIDHUAN. So, for my part is introduction. First, method of production. There are two types of production that are suitable for this product, which is batch and mass production. Batch production is suitable for binoculars that specialize or premium, since the item that need to be produced is for a different type of binocular. Thus, the production would be batch production, so that it is flexible in design. This means that the binocular have many types for military or adventure or other type. That is why a batch production is more suitable. If mass production, it needs to standardize all of the product, but the part of the binocular have a different type. That is why. Next, the function of the component or product. The component that we chosen is on the previous page. First, snap ring, designed to secure the lenses, prism, and the other optical component in place so that the assembly does not lose during use. Next is focus ring, designed to change the distance between the internal lenses and change the focal length. And next, retaining ring, similar to snap ring, it is designed to fasten the lens. And lastly, tube holder, for eyepiece mounting, interpupillary distance adjustment, alignment, and collimation, and focus mechanism integration. So all of this part is in the eyepiece in binocular. For the assumption of the type of manufacturing system, there are three main parts, which is input, process, and output. In input, the raw material need to be obtained first with sufficient amount that can produce a targeted quantity of the production. This is in the shape of ingot or any other raw material that we chosen. So next, a process. First, we develop right concept, finalize all of the plan, and then 3D CAD, which is SolidWorks or any other CAD, and prototype. Yeah, this is for test in real world, and last quality control, which is to check a defect. And then the output, the product is done tested and distributed to the market. Okay, now for the quantity and cost estimation, the quantity is 1000 to 5000 unit. The cost is about 3300. For snap ring, we can see that the total is 756, and the snap ring is 541. The focus ring and tip holder, because since it same material, so we combine it together and the cost is 2000. And lastly, the total sum up is 3297. So we can approximate it to 3300. All of this price is we refer to the Alibaba and Shopee.
Now we come to component analysis. As we see, we have for this part we have snap ring. For snap ring, we know that snap ring it is to improve durability and reduce the cost. So the competitors nowadays for snap ring is looking for aspect for product quality, pricing, and technological innovation. For common materials for snap ring, the properties that required in snap ring is high strength, durability, and corrosion resistant. And for manufacturing process, snap ring is often included in machining, forging, tempering, and turning. And the machine involved in producing snap ring is CNC machine, surface finishing equipment, and quality control instruments. Okay, now we have another part, which is focus ring. For focus ring, we know that in binoculars, focus ring is mostly focused in adjusting the central focusing for an eyepiece, which is the lens of the binoculars. In terms of competitors, we know that in aspect of competitors, we usually concerned about the aspect in design innovation and ergonomic of the focus ring. So the most common material properties for this part is ergonomic and so that it is comfortable for the user to use, and durability, and also resist wear so that it can provide smooth rotation when adjusting the focus lens. And next one is the manufacturing process for focus ring. Focus ring usually may include machining, milling, thread cutting, and coating processes. And the machine that will be involved in this manufacturing process will be milling machine, lathe, and surface finishing equipment. For the third component is retaining ring. This retaining ring help in secure the assembly and alignment of optical components in binoculars. The competitors may differ in aspect of materials use, pricing, and innovation for design feature. For common materials for this part of binoculars, it is required for it to be corrosion resistant and have a high strength. For the manufacturing process for retaining ring, usually it may include machining, stamping, heat treatment, and plating. And the machine that will be involved is CNC machine, stamping presses, and heat treatment furnace. For the last part is the tube solder. So the purpose for tube solder is to secure the optical tubes. And the aspect for competitors is mostly the competitors will see in the aspect of material use, wear resistance, and durability. And for the properties that we seek is high strength, stability, and also resistant to environment factors. And for the manufacturing processes may include cutting, molding, anodizing, and hole drilling. And the machine that involved in all these processes is injection molding and cutting machine. Now we try to find the suitable material for snap ring. So for the first part, we have chosen three type of materials to differentiate whether it is which material is the best one in order to be used for snap ring. So the first one is carbon steel, which has moderate lightweight, high tensile strength, high hardness, and moderate ductility, and also high resistance. For second one, we have aluminum, which high lightweight, low tensile strength, low hardness, high ductility, and moderate wear resistance. And the last one, we have alloy steel, which moderate lightweight, high tensile strength, moderate hardness, moderate ductility, and moderate wear resistance. So based on these three materials, we can see that carbon steel has the best properties compared to aluminum and alloy steel. Because of that, our group has chosen carbon steel as our material for snap ring. Now we are choosing material for focus ring and tube solder. Because we choose these two as together because these two is one of the part of binocular bodies. So for these two parts, we use the same materials and we compare three materials, which is polyethylene, ABS, and PVC. So between these three material, for polyethylene, we know that strength, durability, heat resistance, and impact resistance are very low. So the only high is chemical resistance. While for ABS, it has a high strength, durability, heat resistance, impact resistance, and chemical resistance. For PVC, it has a high durability, heat resistance, and chemical resistance. However, it has a low strength and low impact resistance. So based on these three materials, we have decided to use ABS, which is acrylonitrile butane styrene, as our material for focus ring and tube solder. And lastly is material selection for retaining rings. As for retaining rings, we can see that we also have chosen three material, which is anodized aluminum, normal aluminum, and titanium. For this part, we see that anodized aluminum have a high lightweight, low hardness, high corrosion resistance, and moderate cost. For normal aluminum, we have high lightweight, also low hardness, but moderate corrosion resistance, and also low cost. for titanium, we have low like weight, which is a bit heavy, and high hardness, corrosion resistance, and cost. So based on these three, the most logic is between anodized aluminium and normal aluminium. However, because of retaining ring, we are looking for corrosion resistant. So because of that, our group have decided to use anodized aluminium as material for retaining ring because it has slightly higher corrosion resistance compared to normal aluminium. Thank you.
For the process of manufacturing of a snap ring, first design and engineering. Define the specification for the snap ring considering factors such as material dimension and intended function within the binocular assembly. Second is material selection. Choose a suitable material for the snap ring considering factors like strength, corrosion, and resistance. For the forging, the material is shaped by applying compressive force. Hot or cold forging can be used to create snap ring with improved mechanical properties. For the tempering, apply heat treatment to the formed snap ring to achieve desired mechanical properties such as hardness and strength. For the turning, use precision machining process to refine the snap ring shape and achieve accurate dimension. Surface treatment. Apply surface treatment like coating or plating to enhance the snap ring's corrosion resistance and appearance. For the quality control, inspect the snap ring for dimensional accuracy, surface finish, and any defect that may affect functionality. For the last one, which is testing, ensure that the snap ring function as intended within the monocular assembly. For the process of manufacturing of a focus ring, first is design and engineering. Define the specification for the focus ring considering dimensions, material, and ergonomic factors. Second is material selection. Choose a suitable material based on the desired properties such as durability, corrosion, and weight. Next is milling. Utilize machining process such as milling or turning to achieve the precise shape and dimensions of the focus ring. Integrate any necessary features such as groove for grip or marking for calibration. Next is thread cutting. If the focus ring involves thread component, perform thread cutting to ensure accurate and smooth adjustment. For the coating, apply surface treatment like coating or anodizing for enhanced durability, corrosion resistance, and a refined appearance. For the quality control, inspect the focus ring for dimensional accuracy, surface finish, and any defects that may affect functionality. For the last one, testing. Conduct functional tests to ensure smooth and precise movement of the focus ring, verifying its performance in adjusting the binocular optics. For the process of manufacturing of a retaining ring, first, design and engineering. Define the specification for the retaining considering factors such as material, dimension, tolerance, and intended application. For the material selection, choose a suitable material based on the specific requirement of the retaining ring, considering factors like strength, corrosion resistance, and cost. For the stamping, utilize forming process to shape the raw materials into the circular form of the retaining ring. For the heat treatment, apply the heat treatment to the foam retaining ring to achieve the desired mechanical properties such as a hardness and strength. For the plating, apply surface treatment to enhance the retaining ring's corrosion resistance and appearance. For the quality control, inspect the retaining ring for dimensional accuracy, surface finish, and overall quality. For the last one, which is testing, conduct functionality tests to ensure that the retaining ring meets the performance requirements such as proper fit and strength. For the manufacturing of a tube holder, first design and engineering. Create a detailed design of the tube holder considering factors such as size, shape, material specification, and compatibility with a binocular structure. For the material selection, choose appropriate material for the tube holder based on the factor like strength, weight, and durability. For the cutting, use cutting process to shape the material into the initial form of the tube holder. This involves removing excess material and forming the basic structure. For the molding, employ forming process to achieve the final shape of the tube holder. This may involve specialized tool and dies to ensure precision. For the hole drilling, drill holes and create assembly points as needed for attaching the tube holder to the binocular body. This step is crucial for the final assembly of the binocular. For the anodizing, apply surface finishing process to enhance the appearance and protect the tip holder from corrosion or wear. For the quality control, implement quality control measures at various stages to ensure that the tube holder meets specification standard. This may involve dimension checks, visual inspection, and functional tests. For the testing, conduct tests to verify the tip holder's performance and durability. This could include stress tests, load tests, or environmental tests depending on the intended use of the binocular.
So next is the engineering application of GD&T in technical drawing. So GD&T is a vital in binocular technical drawing, communicating precise manufacturing requirement through symbol. Annotation convey details like lens placement, alignment on lens centering, angular alignment, and surface flatness for optimal optical performance. Its application is essential for consistent quality in binocular production. Okay, so for the next point is the importance of GD&T in the context of binocular design. So we have 8 points here. So the first point is optical alignment. GD&T set tolerance for optical elements ensuring precise lens alignment and centering within defined limits, crucial for clear, distortion-free vision in binoculars. Next, we have mechanical fits and function. GD&T set tolerance for mechanical components, ensuring smooth, precise movement for user-friendly functionality. And for the third point is form and profile control. GD&T symbol define permissible variation in critical feature, ensuring aerodynamic, aesthetic, and design integrity of binocular. Next, assembly requirements. GD&T annotation guide assembly specify precise component fitting and intended alignment for seamless integration. Next, minimizing manufacturing variability. GD&T minimizes manufacturing variation by standardizing design communication, reducing defects, and improving part consistency. And for the sixth point is cost efficiency. GD&T defines tolerance, reducing scrap rework costs and enhancing production efficiency. And for the second last point is quality assurance. Quality assurance. GD&T specify geometric limit for consistent design adherence in binocular manufacturing, fostering customer satisfaction and trust. And lastly is compliance with standard. GD&T ensure binocular meets precision standards for reliable performance.
Each products have different type of machine that are used because they have different process. For snap ring, we use forging and tempering and turning. For this process, we use closed die forging machine and hollow forging machine for the forging process. For the tempering process, we use vacuum furnace and tempering oven. As for the turning process, we only use lathe machine. For focusing product, we only do milling process, thread cutting process, and also coating process. For milling process, we use CNC milling machine, and for the thread cutting process, we use tapping machine and thread milling machine. For the coating process, we use pre-coating machine or deep coating machine. For the reading product, we only do milling process and metal plating process. For the milling process, we use stamping press machine and also draw stamp press machine. For the metal plating process, we use electroplating machine and vacuum plating machine. For the chip holder product, we use cutting process, molding process, and anodizing process. For the cutting process, we only use CNC milling machine. For the molding process, we only use injection molding machine. And for the anodizing process, we only use anodizing rectifiers. Next, it is important to also do sustainability for the environment, which is green manufacturing. For the first step, we can do material selection. We should choose materials with low environmental impact, such as recycled or sustainable materials. We should reduce the amount of dangerous materials used in manufacturing and choose materials that can be readily recycled or broken down by nature. Second, we can also do energy efficient manufacturing process. We should invest in machinery and equipment that uses less energy. We should use strategies like adopting energy efficient lighting system, streamlining manufacturing schedule to reduce energy use during the hours, and also utilizing renewable energy sources. We should, third, we can also do waste reduction. We should reduce waste by making the most use of the materials and cutting down on scraps. Establish recycling initiatives for things including paper, plastic, and metal. We should establish protocols to ensure that hazardous waste is disposed of properly. Fourth, we can focus on water conservation. We should make effective use of water in production operation and consider putting water recycling systems in place. We should reduce water usage by using eco-friendly cleaning solutions and cooling system optimization. For six, that we should design for sustainability. We should make items long-lasting and repairable by designing them with longevity in mind. We should consider modular design that facilitates simpler recycling and disassembly at the end of a product's life cycle. Six, we can focus on green packaging. We should select environmentally appropriate materials for packaging and create waste-free packaging designs. We should adopt design for packaging that are easily recyclable and whenever feasible, use recycled materials. We should also focus on employee training, which is training the employees on environmental best practices and encourage a culture of sustainability. We should engage employees in continuous improvement initiatives to identify and implement green manufacturing solutions. 8. We can focus on life cycle analysis to evaluate the binocular's environmental impact from raw material extraction to disposal. Do a life cycle study. We should determine where improvement can be made and give priority to areas where sustainability advantages can be realized. Other than that, we should focus on lean manufacturing, which is to use lean manufacturing techniques to cut back on wasteful procedures, inventory, and shipping. Process simplification in production can lead to lower energy and waste usage. Other than that, we should focus on supplier sustainability. We should collaborate with vendors who have the same dedication to sustainability. We should select vendors that uphold moral labor standards and environmentally conscious methods. Besides that, we should also comply with environmental regulation. We should remain knowledgeable and abide by regional, governmental, and global environmental laws. To guarantee compliance, audit and evaluate manufacturing processes on a regular basis. Finally, we can also get certification and tenders. We should obtain certifications such as ISO 14001 for environmental management systems or adhere to other recognized sustainability standards to demonstrate your commitment to green manufacturing.
Okay, for the conclusion, binocular are most suitable tool to watch an object in a long distance and that has been used in many sectors. So snap ring use carbon steel material undergoes drawing and machining process, and focus ring made of ABS using milling, thread cutting, and coating. Retaining ring made of anodized aluminum undergoes stamping and plating process. And lastly, tube holder made of ABS, same as focus ring, using cutting and molding process. So that's all from us. Thank you.